careful when you copy down the indefinite integral. Just check it over, make sure you've got it written down properly when you go to work on it. I know I sometimes write something down incorrectly and then do all that great work, and I'm like, oh man. So just a quick check. Yeah, it looks like it checks out okay. So what we do is we look for u, and then whatever's left over is dv. So we recognize the indefinite integral u dv, and we know our integration by parts then results in uv minus the indefinite integral v du, like so. There's our little road map. Now we just have to take a look at when u is equal to x cubed, the differential du is equal to 3x squared dx. So the differentiation this direction helps us find the differential du. If you want that little intermediate step saying du dx is equal to 3x squared, you can do that. I think we're all pretty comfortable at this point. dv is up next. dv is e to the x dx, and what we're going to do is we're going to integrate to undo this differential, revealing v is equal to e to the x. The uv is this part right here, uv. So as I find u times v, it's equal to x cubed e to the x. Then I subtract the indefinite integral v with respect to u, which is going to be, well, I've got a 3 x squared e to the x dx in here. It looks like so. I'm going to grab my green pen and just circle this part right here. I've got part of my answer, and now I need to take a look at what's happening here. So I'm just going to copy that down. We used our integration by parts. One time so far. But now we need to investigate this, and, well, we're going to do it again. There we go. So we examine it again, and we just repeat the process. U will let u equal 3x squared, and then the remaining dv. So note, we could put the 3 in front of the integral symbol and have a negative 3 out here if we wish. Since I've already written it down, we'll just go ahead and work with this. It should be fine. I mean, it will be fine. du is 6x dx, dv is equal to e to the x dx. We know what v is by integration. It's e to the x. I'll just use this road map from up above. I don't think I need to write this down again. But it is important I put that negative sign out here. That negative sign is right here. Had I left the 3 or placed a 3 in front of it, I'd have a negative 3, and then u would have been x squared and du would have been 2x dx. But it all works out for us here. I'm just going to put a bracket just so I can say then uv (3x squared e to the x) minus, remember I'm just following along with this roadmap here, 6x e to the x dx, like so. I'm going to distribute this negative sign through here just to make it a little easier for me to keep track of what I've found. Plus, here we go. Like that. Grab that green pen. I found another piece of the puzzle by using my integration by parts a second time. Now we have to tackle this one, so looks like integration by parts again. Let's see what happens. Looks like this. I'm going to let u equal 6x. du is equal to 6 dx. dv and v. So we'll use our integration by parts, following this uv minus the indefinite integral of v du. Six x e to the x minus, let's see what happens now. It's looking promising. I've got another piece of the puzzle right here, the 6x e to the x. And now I'm going to integrate this one, which that looks like it'll be pretty easy to do. Got the last piece of the puzzle right there. So what I'm going to do is I'm going to collect all of the expressions that are summed together so that I can state this indefinite integral. I'm going to copy this down one last time. I have room right at the bottom. Now I'm going to pick up all those parts that I found. There we go, I got all the parts in. We'll put our constant of integration there for good measure. Just to summarize, we ended up using integration by parts 3 times to find the indefinite integral. I'm just going to put a little box around it. We're pretty excited that we found it. And of course what we can do if we like, we can check by differentiation to see if we get back to our integrand right here. You will. It's right.